Hello dear students, in this video lecture we will study cubic spline interpolation formula. We have the data points x0, y0, x1, y1. To be continuing, we get xn, yn is our last point. And our goal is to fit piecewise cubic polynomials si of x over each interval xi, x of I plus 1 such that si of x is equal to ai plus bi multiplied by x minus xi plus ci multiplied by x minus xi whole square plus di multiplied by x minus xi whole cube plus dot dot. Let hi is equal to x of I plus 1 minus xi. And we define our second derivatives at the knot such as mi is equal to s double dash of xi. Now from Taylor's approximation and spline properties, we can write y of I plus 1 minus yi divided by h of I is equal to hi divided by 6 multiplied by m of I plus 1 plus our linear term, which leads to the spline equation. And the spline equation is given by mu I multiplied by m of I minus 1 plus 2mi plus lambda I multiplied by mi plus 1 is equal to di, where mu I is equal to h of I divided by h of I plus h of I plus 1, comma lambda of I is equal to 1 minus mu I and di is equal to 6 divided by hi plus h of I plus 1 multiplied by the term written in the parenthesis y of I plus 1 minus yi divided by h of I plus 1 minus yi minus y of I minus 1 divided by hi. So this is our cubic spline interpolation formula. Mu I multiplied by m of I minus 1 plus 2mi plus lambda I m of I plus 1 is equal to di. And how we reach this interpolating formula? We had our interpolating polynomial si of x is equal to ai plus bi of x minus xi plus ci of x minus xi whole square plus di of x minus xi whole cube dot dot. We had our given data points x0, y0, x1, y1, comma dot dot xn, yn, and we thought or we supposed hi is equal to xi plus 1 minus xi, and we defined our second derivatives at the knots as mi is equal to s double dash of xi. And using Taylor's approximation and spline properties, we put yi plus 1 minus yi divided by hi is equal to hi by 6 multiplied by m of I plus 1 plus linear term. That led us to the spline equation. So this much for today. Thank you.